we're going to learn our third method of solving a quadratic. This is the first method we had that always works. There's no restriction on what the quadratic has to look like in order to be able to solve by this method. It's called completing the square. Now, of course, you give up something for having a method that always works. This is the hardest method we will learn. So, completing the square involves mimicking a factorization into a perfect square. So throughout what we do, we are going to try and mimic this. So, the first step. Well, first of all, although it is possible to solve directly with a number in front of x squared, it makes it 5 times harder. So we are going to avoid having a number in front of x squared. So in this one, we don't have such a number, we don't have to deal with it. The first step to completing the square after getting the x squared term alone is to kick the constant term over to the other side. The constant term being the term without any x's. Notice I left this space right here because it's going to be very important. Now, we are mimicking this equation. And you notice that x squared and x squared, they match perfectly. In order for the middle term, 4x, to match the middle term here, 2dx, the 4 must equal the 2d. Namely, this tells us that d is 2. Notice, by the way that we are always mimicking a 2d term, d is always going to be this number divided by 2. So, what we now do is we need to mimic the third term. The third term is d squared. Since d was 2, I'm adding 4 there. But this is an equation. You can't just add 4 to one side and expect everything to still work. Since I added 4 to this side, I have to add 4 to the other side as well. Now, the left-hand side has perfectly mimicked the left-hand side of the perfect square, so it will factor as x plus 2 squared. I didn't even think about that factorization, even though we do have techniques to do it, because it will always be x plus d quantity squared, because I forced it to be that. Now the right-hand side, 6 plus 4 must be 10. This should look familiar, because from here on out, the way we're going to solve it is to extract a root. The squared term is alone. I take a square root of both sides, and remember the plus minus, and then I solve for x directly. All right, let's move on to our next example. This one has that pesky little 4 in front of the x squared, and that is going to make it so much harder that we're going to get rid of it before we do anything else. And the way to get rid of it is to divide everything in the equation by that 4. Now, we have fractions. You may say this makes the problem so much worse, except for the fact that we're never really going to have to do much beyond adding them. So, I start where I did on the last one, which is to kick the constant term over to the other side. Now I say I need to know what d is. As we learned, d is always found by taking the middle coefficient, the number in front of x, and dividing it by 2. That gives me a d of 3/8. Then the third term that's missing is always d squared. So I square this, I get 9/64. And I have to remember to add it to both sides of the equation. Now, you may look at this and say, I don't know how to factor things with fractions. Well, I don't either. But I don't have to factor it because it factors for me always as x plus d squared. Now, this other side I do have to add fractions a little bit. If you remember, to be able to add fractions, I have to get a common denominator. So this 1/4 is going to become 16/64, and I end up with 25/64. All right, next step is to take a square root of both sides. X plus 3/8 on this side. Here, if I take a square root of the fraction, on top I get 5, on bottom I get 8. You must remember the plus minus in front. Then I solve for x. X is minus 3/8 plus or minus 5/8. Now you notice this one's a little bit different than the ones we've seen before. There are no square roots left, which means we should be able to actually get nice, pretty answers without this pesky plus minus in the middle. So, my first answer is minus 3/8 plus 5/8, which is 2/8. My second answer is minus 3/8 minus 5/8, which is minus 8/8. You can clean these up, of course, to 1/4 and minus 1. Those give me my final answers. Now, for our last one, we again have that pesky number in front of x squared, so I'm going to divide by it. Then the first step of completing a square is to kick over the constant term. Now I say, well, what is d? D is you take this lovely number in front of x and you divide it by 2, giving me a d of 1/3. When I square that, it tells me that I'm adding 1/9 on both sides. Now, the left-hand side, as always, factors as x plus d, quantity squared. The right-hand side we see is 26/9. I take a square root of both sides. Remember the plus minus. And then I solve for x directly. So, once again, to complete the square, you first get rid of the number in front of x squared, move the constant term over, and figure out what d is, and then proceed to solve by extracting a root.